Hey, and welcome to the bonus video for our blend shader lesson. In this video we're going to go over some more advanced techniques in order to leverage the full potential of our ShaderFX blend material. In this first part of the video we're going to talk about using Turtle, my LT's built-in renderer, to bake occlusion information to speed up our workflow. When we paint our grime using the vertex colors, it's important to remember that we want an accurate representation of where we would expect it to gather in real life. Typically we would see quite a bit under the windows, overhangs, or in corners. This corresponds nicely with where we would expect occlusion shadowing to occur. Because of this, we can use Turtle to bake an occlusion pass directly to the vertices, eliminating some of the hand painting required to give our mesh a nice realistic weathered look. So inside of my LT, I went ahead and duplicated our master material and assigned all the correct textures, and then applied them to each one of our house meshes. I saved that as oldhouse_finish.mlt, and I've included that in the downloads folder, so for this video you can go ahead and just open that up. Pretty much everything else is exactly the same. I have added a couple of extra edge loops to our mesh here to where I think some natural shadowing is going to occur. There are a couple of things that I want to do before we get started with Turtle. The first thing on our oldhouse_wood_01 material, I'm going to go ahead and open ShaderFX. And up near the diffuse linear interpolate at the top, we're going to replace this with a new one. So I'm just going to go to Math Linear Interpolate Mix. And then I'm going to create two color nodes. So values color. And I'm going to duplicate that, and I'm going to rename our second color here detail color, and we're going to change that to a red color. And then we're going to create a vertex color under inputs common. I'm going to plug this in, so our RGB texture of our first color goes into the value on our linear interpolate. Looks like I didn't grab the red here. And the second detail color goes into the second value on our linear interpolate, and the alpha of our vertex color goes into the mix. And then I'm going to grab the result and plug that into the diffuse color. You should see your mesh turns gray. This is going to allow us to visualize our baking process a lot easier. I'm going to close down ShaderFX now. The second thing that I want to do is make sure that we have a color set on our mesh here, so just click on that and go up to Color, Color Set Editor, and make sure that you have a color set on here and it's named appropriately. If for some reason it's gone, you can just hit New, and remember the settings that we used last time. Color range is clamped, and we're going to want to use an RGBA component, and just hit Apply, and we can close down both these windows. So now we're ready to get started with Turtle. So under Window, we're going to go to Material and Texture Baking Editors and click the Texture Baking Settings here. And that'll bring up the dialog box for Turtle. Turtle is a fairly advanced renderer and baking solution for MyLT, and it can be used for a various number of different things, including baking occlusion maps and normal maps into textures. In this case, we're going to be baking some occlusion information down to vertices. We're going to go over some settings. So under Type, make sure that you have Bake selected. Under the Global Illumination tab, make sure you turn that off. Under the Environment tab, make sure that you have GI Environment selected to None. The default for options should be good. And then under Baking, there are a couple of different things that we have to set here. Your bake layer should be set to Turtle Default Bake Layer. And then we're going to be wanting to bake to vertices, not textures, so make sure that you have that selected. Under Targets, we're going to have Bake Selected Surfaces enabled. If you want to do multiple different bakes on various different meshes at the same time, you can turn that off and add them here. But in this case, we're just going to be doing one at a time, so just make sure that Bake Selected Surfaces is on. Under Transfer Settings, the default should be good. Then under Common, the default also should be good, so just make sure that you have Surface Front, Bake Shadows, and Bake Alpha on. We can skip the Texture Baking settings because we're going to be using the Vertex Baking. And there are a couple of things that we have to set here. The default sampling mode here is good. This will allow for a fairly advanced level of fidelity. If you want to increase some of the accuracy of your bake, you can adjust these values. But because we only have a few vertices here, it won't really make that much of a difference for us. Next, make sure to have Save and Overwrite to Color Set on. And under the color set name here, just make sure that you have that named appropriately to Color Set. Next, under Blending, you want to make sure that you have Blend Old Colors selected. Our RGB blending can be set to None, because we're not going to be doing any RGB information here. And then our Alpha blending, there are a bunch of different options we'll go over in a second. The defaults for RGB and alpha scale should be fine. Make sure that you have clamped enabled, and that your alpha min is 0 and your alpha max is 1. We have the enable vertex color filter here. I don't typically enable that because it does blur out some of the color information. When you're baking with a denser mesh, this can become fairly important, but for us, again, it's not that important here. So under outputs, make sure that your shader outputs, you have nothing selected. And finally, under directional occlusion mapping, make sure that you have that enabled. So the defaults for that should be fine. You can increase the number of samples. Again, it won't make that much of a difference because we are baking a fairly low dense mesh. The exponent is used to define the sharpness of the occlusion values. Higher values can produce a much clearer effect. I like to fiddle with this while I'm baking, so I'm just going to leave the exponent at 1 for now. So there is no one correct way to go about rendering this information. Most of the time it requires a number of bakes to get a good look, and this is where the blend technique on the alpha blending drop down here is important. I'm going to show you the settings and process I typically use to get good results, and then you can play around and come up with a way that maybe works better for you. So the first thing that I do is set all of my alpha values on our mesh here to 1. So under color, go to apply color and hit the little square here. Our operation we want to set to replace color, and then effect I want individual channels selected. Red, green, blue are all set to off. My alpha here is set on, and I want that at 1, and I just hit apply. And that'll turn my mesh here red, and I can hit close. Then under the alpha blending here, I want to subtract. So essentially what I'm going to be doing is having the alpha values all set to 1, and I'm going to subtract the occlusion information. So now we're ready to bake. So under Window, go to Material and Texture Baking Editors, and hit the Texture Baking view here. That'll bring up your commands for the texture bake. And you can just hit this purple and brown button here, which is the Bake Turtle button. And that'll perform the command. And if I zoom in here, you can see that under the overhangs and in the corners, perhaps under the windows here, you can see that we've got a stronger red, and on the flat surfaces where we don't have much shadow, the gray is more apparent. Now it does take a couple of different bakes, like I said, to get a really good effect, so I'm just going to fool around here a little bit and see what I can come up with. Perhaps set the alpha scale to 0.25 and do another subtract. Maybe one more time, and that looks pretty good. One thing that you can do here is increase this using the modify color set. So under color, we're just going to hit the modify current color set button, and that'll bring up the attribute editor here. Yours might look a little bit like this, and we can adjust the hue, saturation, value, and intensity of the vertex colors here. And we can do that under the color channel modifier. We can do that each channel independently, which is pretty cool because we just want to adjust the alpha intensity here. So I'm just going to click on the graph here, and I'm going to add a point, and I'm going to adjust my selected position here to 0.5 and bring the selected value up to probably 0.75 or something like that. And that looks pretty good to me. Not bad. So essentially what I'm looking for is to make sure that under the overhangs I have a fairly intense red, and on these flatter surface areas it's a little bit grayer. I might want to do one more subtract and an exponent that's a little bit higher, 0.3 perhaps. I'm sorry, 3. That looks pretty good in my opinion. So now that we've done that, we can hook up our wood texture map back into the diffuse so we don't see this red, and we can really get a sense of what's going on with our grime texture here. So I'm just going to go over to our oldhouse_wood01 and open ShaderFX. And now we can grab our diffuse linear interpolate here and plug that back into the diffuse color. And we can close ShaderFX again. So now you can see that where our red was showing up, we've got some of the grime texture showing on our mesh here. And remember that we can adjust the blend intensity via the shader as well. So I might want to bring that up to 1.5 perhaps, and bring our fall off maybe up to 1.25. Now you can use Turtle while we've got this texture map hooked up again. So if you want to just go ahead and maybe tweak it while you've got the texture set up, you can do that as well. So I might just do an add here and see what I can come up with. One thing you do want to make sure is that you don't get an effect that's too overwhelming. You can see in this corner here, the grime is a little bit too much. You can adjust that by hand. I might do it via Turtle again, so I'm just going to do subtract again. And maybe this time I enable the vertex color filter so that I'm doing a little bit of a more blurry pass. So I might just do a subtract here. And that's starting to look a little bit better. Underneath the porch here, we've got a little bit too much of a grime texture going on. So you might want to go in with your paint vertex color tool and subtract a little bit of that. So if I close down Turtle, close my outliner, and just do a subtract our alpha value. You can reduce some of the effect on the porch in a localized manner. I've used this process to get a base layer of color information down really quick on a number of assets for games I've worked on in the past. Coupled with some hand painting with the Paint Vertex color tool, like I'm doing here, you can produce some nice realistic effects. Using extension 2 for MyLT, you can also write a mel script to assign and execute the turtle commands, which can speed up the workflow even more. I hope you enjoyed the first bonus tip here on using Turtle to make occlusion information to vertices. In part 2 of the bonus video, we're going to discuss integrating a wetness feature into our shader. Although you can use ShaderFX to generate procedural UVs onto your mesh and world space, we're going to be using the existing UVs of our house mesh. So just keep in mind that this technique will only look convincing on assets where the UV map is fairly straight on the horizontal axis and unwrapped in large sections. Here we're going to be generating a mask to interpolate between a wet look for our shaders diffuse, spec, glossiness, normal, and reflection. Our feature here will focus mainly on getting vertical rain streaks on the walls as opposed to puddles on the ground, but using the same information taught, you can quickly adjust the shader to use a puddle mask instead. This is a fairly advanced video, so if you do get stuck at any point, feel free to post on the Autodesk forums. Inside of MyLT, we're going to continue to use our wood 01 shader, so just get your mesh here and open up ShaderFX. First thing that I want to do is just grab all of our stuff here and create a new group. So I'm going to left click and drag and just go up to group, create group, and I'm going to call this the grunge blend. And next we can go ahead and import our wetness texture that we're going to use as our mask. So I'm just going to go to hardware shader nodes, textures, texture map. And I'm going to rename this to wetness mask. And I'm just going to type that also into the unique name as well. And I'm going to expose that to Maya. And we're going to go to our path here. And we want wetness mask 01. I'm just going to hit open. So inside of Photoshop, I'm going to show you what that looks like. And it's a pretty simple texture map here. I just drew a couple of lines and did a filter blur, motion blur, and added a little bit of detail on the top of it. And it looks like some rain dripping down the side of a window, maybe a wall or something like that. So back inside of ShaderFX, we want to create a contrast algorithm that will allow us to define the blurriness of our wetness mask, or how sharp it's going to look. So I'm just going to go ahead and drag this over to the side, and I'm going to create a couple of float values. So the first one here I'm going to name contrast, and I'm going to copy and paste that twice. And the first copy I'm going to name min, and I want the value to be 0. And the second contrast that I pasted here is going to become max, and that value is going to stay at 1. Next, under math, we want to create a add and subtract command. So math add and math subtract. I'm going to bring our contrast over to the left hand side here, and we want the min value to go into the first value on our subtract, and then our contrast will wire into the second value on our subtract. Then we can put our contrast into the first value of our add, and put the max into the second value of our add. Then we're going to create a linear interpolate, so math linear interpolate. And the subtract is going to go into the first value, and the add goes into the second value. And then we're going to grab the red channel of our mask here and plug that into the mix. Going to bring everything over a little bit. And we're going to want to finally create a clamp. So under math, go to clamp. We're going to create two float values for the min and max. So math float. Just copy and paste that. Our first float goes to 0 in the value, and that gets wired into the min. And then our second float can stay at 1, and that gets wired into the max. We grab our linear interpolate and plug that into the value. So just to give you a sense of what's going on here, we're going to multiply our clamp here with a color node. So math multiply, grab the result and plug that into the multiply. Then we can go to values, color, and plug the RGB into our multiply. Can move it over a little bit. And now to visualize what's going on, we can grab the multiply and plug it into our diffuse on our surface shader. And if we zoom into our mesh here, as we adjust our contrast float here, you can see that it's tightening up the wetness mask here quite a bit. So that's working pretty well. I'm just going to go ahead and create a group from those values as well. So we're going to delete the multiply with the color here. And just grab everything here except for the wetness mask and create a group. And I'm going to call the group node contrast function. Now you will see on the left hand side there's nothing coming outside of our group. There's no exposed values. This is because inside of our group we don't have anything plugged into the output of our group node. So we're just going to grab the clamp result and just drop that onto the 0 any slot. And this will change to result here, the text. And if you exit the group, you should have now the result output on your group. I'm just going to do one last thing inside of our contrast function. I want to take our contrast float here, rename it to wetness contrast, and I want to enable the input from Maya button here so that we can adjust our contrast of the wetness inside the attribute editor. Now that our contrast function is complete, we're going to want to create the linear interpolates for each one of our outputs of the grunge blend here. So I'm just going to go to math linear interpolate and duplicate that 6 times like we did before. Next I'm going to rename them, so this is going to become diffuse wetness lerp. I'm just going to copy and paste this name and rename them. Now I can wire each one of our grunge blend outputs into the first value of each one of our lerps. Next, we're going to grab our contrast function result and plug that into the mix. So because water really only adjusts the surface look of a material, we don't really need to make any unique textures for our wetness look. All we're going to be doing is altering the information on our main material here with a few math nodes. First, we can expect that our diffuse contribution darkens when there's water covering the object. So we're simply going to be using a power operation on that. So I'm going to move this over, and go to Math, Power. And I'm going to grab the diffuse color and plug that into the X of our power. And I'm going to create a float value. And I'm going to put that float value to 1.4. Whoops. Plug that into the Y input on our power, and just grab that result and plug that into our diffuse linear interpolate. Next, for our glossiness, we're going to just use a float value. So I'm going to copy and paste our float here, and I'm going to rename it to wetness gloss. I'm going to put that value to 0.4, and I can plug that float into our glossiness linear interpolate. We're going to multiply our specular color by a slight value, so I'm just going to go to Math, Multiply. We want to grab our specular color output here, and grab a float value. We're just going to multiply it times 1.25. We can grab that multiply and plug it into the second value on our specular wetness linear interpolate. Move some things out of the way, and I'm also going to delete these connections for now. For our normal, we're going to actually add to our Z value, so we just need to do a math add. I'm going to create some more room here. Grab the normal output of our main group, plug that into the value. Then we're going to go to values float 3, and I want our value to be 0 on the X and Y, and then 0.4 on the Z. And we can add that, plug that into our add. And then if you make any adjustments to your normal, typically you want to use a normalize command after that. So under Math, we're just going to grab the normalize and plug that result of our add into there, and now we can grab that result and plug that into the normal wetness linear interpolate. For the reflection wetness, we're actually going to delete that linear interpolate. We don't need that because we're not going to be adjusting the reflection map, so we can just delete that for now. And finally, for our reflection intensity, we're just going to create a float and call it reflection wetness reflection intensity, and we're going to change that value to 0.25 and turn on input from Maya. Then we can grab that float and plug it into the second value of our reflection intensity. Now we can take the result of our linear interpolates and plug them into the surface shader. So I'm going to go ahead and do that. And just remember to grab your reflection from our main group here and plug that back into the reflection of our surface shader. So now if we grab ShaderFX window, move that over to the side, we can get a look at our house here with the wetness on it. So that looks pretty good. There are a few things that I do want to adjust here. The reflection intensity looks pretty high. So I'm just going to grab our wetness reflection intensity float here. Looks like 0.05 is going to work best. The next thing that I want to add to our wetness mask here is an overall opacity. So I'm just going to grab the contrast function, move it over to the side, and grab a math multiply, and we're going to put it between the texture map and the contrast function. So I'm just going to grab the red channel, put that into our multiply, and grab a float value and plug that into our multiply. I'm going to rename this float value wetness opacity, and I'm going to grab the result and plug that back into our contrast. And now you can see as I grab the value and bring it down a little bit, the wetness disappears. And we're going to expose that to Maya as well, so I'm just going to turn on the input from Maya. Now if we close down ShaderFX, all of those attributes should be there in the attribute editor, so we can adjust them on the fly. If we adjust our wetness contrast, you can see that the contrast of our texture map is a little bit less. If we can bring it up even further, so if we were to make it, for example, 2, it gets much of a harder drawn mask here. I'm going to put that back to 1, and we can lower our wetness opacity, and the effect goes away as well. So that looks pretty good. The last feature that I want to add here to our wetness is the ability to have the texture pan. So I want it to look like it's animating down the side of the wall here. And that's pretty simple. All we have to do is jump back into ShaderFX, navigate over to our wetness mask here. We're going to create a textures UV panner. We're going to plug the panned UV output into the input UV on our texture map. Make sure that Play Animated Shaders is on in our settings. I'm going to turn on my time slider and my range slider. Going to bring the range up to probably 120. And now if we play the animation, you're going to see that it's animating both on the U and V. So we just need to change the attributes of our UV panner here. We can change the hue speed to 0 because we don't want it to go on the horizon, but we do want it to go up and down on the V, and we can change it to probably 0.2, and that'll look pretty good. So if we close ShaderFX and play the animation, oh, it looks like it's going backwards. So just pop back into ShaderFX, grab our UV panner and make sure that we set the V to -0.2. Now I can close down ShaderFX. We can play it, and it looks pretty good. So that about wraps it up for our wetness feature. This is a fairly modular approach to wetness, so if you wanted to add in a puddle map, you can just replace the wall streaks with a cloud texture and turn off the UV panner. Then you can multiply with the vertex color in order to define where the puddle appears on your asset. I hope you enjoyed this bonus feature video for the blend shader, and I'll see you in the next video.